All right. So thanks everyone for attending our monthly meeting. And now we haven't had one for a little bit. We did have to stop doing it for COVID, but I think all of us have had to realize that COVID isn't going away as quickly as we thought. So we'll just have to adapt. For those of you that have been to one of these meetings, they're quite informal usually. We just kind of go over some of the things that have been going on since we last met, and then we usually have an introduction. And this time around, we have Francisco from the Art University. He's gonna tell us a little bit about his thesis project. He's looking for people that could potentially want to work with him or give him some information. And then we have Christian from the Swedish Space Corporation. And then afterwards we have questions. With me today is Alpha. She'll be noting your questions if you have any, and we'll, for the Q&A, and sort of keeping tabs on everyone. And then we get to our main speaker, which is Christian from the Swedish Space Corporation. But I think we should start with Francisco if he's ready.
Yeah, sure. Please start with Francisco.
So, Francisco, take it away. What have you got for us?
Yeah, sure. Thank you. I'll just share my screen.
Hang on. Yeah. Yes, there you are.
Can you see it?
Yeah, I think everyone. Yeah. Can everyone see it?
Yeah.
I can see it.
Yeah.
You can?
Okay. Continue, Francisco.
Yeah, great. So, good morning, everyone. My name is Francisco Cuéllar. I am a master design student at the Iceland Academy of the Arts, and I will briefly introduce my thesis research and final project, which is about color perception on Mars and how this modifies the design of tools for the red planet that we will be using in Mars colonization. My project started by reviewing the studies regarding vision problems by the fluid shift and studies aboard the International Space Station, where it shows microgravity caused different vision problems. As you can see in the pictures, there are some studies regarding that. A lot of information has been, or problems has been detected around this topic. Some experiments that people in the International Space Station have been doing, and also here on Earth. And also, after that, I looked into some of these problems, and these conditions might affect specific parts of the eyes related to our color vision. So, for example, here where the Colorblind Awareness Organization says accidents or strokes that damage the retina or affect particular areas of the brain eye can lead to color blindness. So in the in the previous research here, as you can see, the astronauts, they are talking about I mean, this is all in the NASA webpage. You can just look for it. They are talking about how these conditions might affect this specific part of the eyeballs or a specific part of the retina. And then this is just a link between the vision problems and the possible color blindness problems that the Colorblind Awareness Organization are talking about. And after this, I used like all this information just to start with questions that later transform into a hypothesis and the project itself, which is the idea of a possible link between long exposure to microgravity and color blindness. And then this kind of questions and hypotheses that I had are how will humans' vision be affected on Mars? And is it possible that color blindness rates increase in future generations on Mars in this Mars colonization campaign? From there, I started to work on few explorations and experiments by imitating Martian conditions to understand better the issue and the possibility of color change there in the planet. Maybe color blindness won't appear, but it's clear the extreme weather conditions affect the way we will see in general, also colors. For example, the lack of sunlight, sandstorms, erosion, the color of the atmosphere, and even the color of the helmet visor change the perception of the colors we will have. For example, here I just like made some experiments by mimicking the conditions of the visor, the soil in general, and the color. So you can see like the different colors and how they change. Of course, this is just like an experiment. It's not like really accurate, but it's just to get an idea of how this is important and how this could lead to a bigger problem or not. But of course, it's just like part of the exploration. And then from there, the design of the tools, which I was proposing. It's based on the durability of the materials and patterns and colors used as techniques to help colorblind people. It's based on this color awareness organization, just to follow specific patterns and colors that they used to help these people. So this perhaps will make the tools easy to spot under different conditions. For example, you can see daylight, the night, or even with black light. This will make the tools easier to spot. So this is what I'm working on. And just as a final thing, I'm looking just to go further on the project by testing these ideas, producing the tools, for example, not only for space conditions, but they could be useful when people have to work or face extreme weather conditions all over the world. For example, working in the darkness or survive snowstorms, or as you can see here, like the construction companies or road repairing and so on. And also like this hypothesis of color blindness in the future generations is other topic that I would like to go deeper into by testing these ideas or research more about it. So yeah, I'm just like looking to work with space corporations or on this or even other projects just to be involved in this space scene, which I think it's super relevant. And yeah, that's basically it.
All right, thank you, Francisco. So we'll, if there are any questions, then feel free to let us know and let Alpha know, so he'll take them down. So Space Iceland is always happy to like help people like Francisco to introduce what they're doing, and we tend to be quite happy when any university students show an interest in space. So we'll keep his contact as well, or you can get it if any one of you needs it. We can introduce you guys. Is there anything specific that you want for the thesis, Francisco? Like, do you need an interview subject or anything like that?
Well, nothing like specific right now. I mean, I'm just like looking forward just to kind of get more into this, into the whole context of space. Maybe try to get this into a more serious, scene, or maybe with a corporation or with a more serious research space where I can just take this into a next stage kind of develop it more to make it more relevant, and so more people get to know this project.
All right, thank you. Were there any questions? Were there any questions, or should we move to the other? I don't see any in the chat. Alpha, you haven't got anything?
There's one question here. Excuse me for my English, but
Okay.
what causes the colorblind in space, and how will it affect the travelers to Mars during a long-time travel and probably staying there for years? Thank you.
Yeah, thank you. As I said, it's just like a hypothesis. I mean, what might cause the color blindness in space, it's microgravity, like long exposures to microgravity. It's not like there are no proofs that this is like happening, but I mean vision problems, for example blurred vision, for example astronauts when they come back to Earth after a long when they're like in the International Space Station for long, when they come back, they say they need to wear glasses because they don't see that well anymore. So I was thinking about this link between the vision problems and the problems that this fluid shift at the back of our eyeball kind of moving all the time in microgravity. So here on Earth, it's not moving because, you know, gravity keeps like moving everything, but there it's just like staying in a position where shouldn't be there, and that's causing the problems. And the color blindness organization are talking about like when you like affect some part of the eyeballs, retina, and this connection between the brain and the eye, color blindness might appear. So this is what I'm saying, or what I'm trying to develop more, just the link between the microgravity and the possible color blindness affect people.
All right, thank you. I think I'm happy to introduce our next speaker, or main speaker. That's Christian Krokstedt from Swedish Space Corporation. I'm sorry, Christian, if I wasn't.
It's fine. Everyone messes up my name. It's okay.
Right.
So I can introduce myself. So hi, my name is Christan Krokstedt. So I'm here representing Swedish Space Corporation. I actually have some colleagues with me as well. I have Henrik Pettersson, which is the head of the business development department here at SSC. And also I have Henrik Johansson with me as a fellow colleague and business development director here at Swedish Space Corporation. So a bit of the background here is that we have been having some discussions with Space Iceland about what sort of activities could be expanded between Sweden and Iceland in the field of space. So basically what we've been doing a bit on our end is sort of looking at these potential collaborative areas and see if we could make anything concrete out of it. And actually to try to investigate what is actually the Icelandic willingness to participate in these type of activities together with us. So I put together a little presentation that I wanted to share. But first of all, I'm very impressed with the previous presentation. I would like to say I find it quite fascinating that Elon Musk and all his friends will be colorblind at Mars. Let's see, share the screen. Share and then full screen. Perfect. Can everyone see my screen? Yeah, okay.
Looks fine over here.
Okay, perfect. So I assume it's perfect for everyone. So basically a little bit about Swedish Space Corporation. So we're a governmental dividend company to begin with. So we're owned by the Swedish state, but operate as a private company. And so we're separate from the Swedish Space Agency, which is a fully governmental agency, so to speak, that handles all the financing, and similarly for Swedish domestic space programs, and also the Swedish funding to European space programs like ESA, for example. So the main areas where we are involved are in the science and launch services. So that means that the launching of rockets and stratospheric balloons out of our launch center in northern Sweden, Esrange Space Center. We have one part of the company that's involved in satellite communication. So a lot of near Earth and deep space communication with different types of interplanetary probes, and also geostationary satellites and lower satellites. We also have a team in Germany and the Netherlands involved with spacecraft operations and engineering services, supporting larger European customers and European missions for operations and consultancy services. So one of our prime assets that we operate in northern Sweden is Esrange Space Center. So the size of the launch range together with the impact area is roughly a little bit more than 1% of the total Swedish landmass. So that roughly corresponds to 5,200 square kilometers, or twice the size of Luxembourg, to be in a bit more geographic sense, so to speak. We have quite a long heritage with launching rockets and balloons from Esrange Space Center itself. We started out in basically the beginning of the 60s to start launching rockets, and then a little bit later start launching stratospheric balloons. So the largest rockets we fly from here are up to 12 tons. And the largest balloons that we fly are roughly twice the size of a football stadium and can carry 2.5 tons of experimental payload in circumpolar flights. So basically going Sweden, North America, Russia, and then back. So this is one area of the company where we're very proud of and have a long heritage and expertise. Also with the ground stations that we have spread out all over the planet for doing deep space and near Earth communication, and supporting a large variety of different types of spaceborne missions. So when we started to look a little bit about what we could potentially do together with Iceland and what sort of areas that could be interesting to explore a little bit further, we concluded basically 3 different fields that we wanted to focus on. One of these fields is moon research and moon exploration. We know that Iceland has a lot of heritage in this specific area, and we have active researchers and active projects in this area, and actually in situ testing on Iceland for preparation of Mars rovers and exploration and testing programs and similarly. So we see the potential here that together with our planned activities, with us actually working together with American companies and our own aims, see that there's potential possibilities of working together in this field. So I'll talk a little bit more about that in upcoming slides. Also, we see the possibility of extending our current student programs. So from Esrange Space Center, we operate a number of student programs. One of them is involved with the launching of student payloads on sounding rockets. And another program is involved in launching of student-built rockets from the base itself. So this means that we operate and run these programs and educate the students. And we see that we could potentially extend this to involve Icelandic students to potentially fly them out of Esrange, or as according to the next area that we see, flying them out of Iceland, which we could see is quite interesting. This is based a lot on the activities that have been done with Skyrora now during this year with the recent test launch, which has gathered a lot of interest internationally. And this is sort of opening up to doing more rocket-based activities on Iceland. And one field that we see is that we could potentially help out with how to set up the regulatory framework for doing sounding rocket launching, and also in terms of sort of how to safely vet these rockets so that all of the activities that are being done are safe and within the required regulation and supporting based on our current expertise from operating these types of rockets from Esrange. So starting off with the lunar part, we have quite the heritage here with in terms of lunar missions. We've actually built in the past our own moon mission probe called Smart 1 as part of a European space program to do close proximity flights to the moon with a wide variety of instruments. Also, we have done a lot of supporting for a variety of moon missions. For example, the Israeli Bereshit lander that made quite the headlines. I think it was 1 or 2 years ago, where we supported with the communications for that specific flight, and also working with a large number of large international space agencies on different parts of moon projects. So right now we are working together with American companies to sort of isolate landing sites and see what are the actual potential possibilities of putting down European payloads on the surface of the moon. And this is where we see your heritage in sort of moon-based heritage research comes into play, where you have potentially researchers that could be interested in doing in situ research on the moon, and our heritage in building scientific equipment for sounding rocket and other types of spaceborne missions could come into play. So what we sort of would propose is that we could help Icelandic-based researchers to build instrumentation required for surviving on the surface of the moon, the travel there, and also help out in perform and design the different types of activities that this specific parts of the scientific equipment would perform on the surface of the moon. So when it comes to scientific equipment and our heritage there, we've built quite a number of them, most of them for sounding rockets actually. And that's one of sort of the prime areas where we fly a lot of scientific equipment, for example, in a wide variety of fields, both in life science and in material physics, fluidic physics. So a quite wide variety of experiments that we built. So that means that our engineers that are working on this are quite broad in their knowledge, and it's quite fun to work on this project because usually there's a new challenge for each new payload that we build, because it's usually in another sort of physics or life science niche and that we need to sort of delve into and utilize our full expertise, and also utilize expertise from our past payloads that we built in the past. So this is sort of what we feel that we can bring to the table and work together with Iceland and see if we can make something interesting out of this. Another that I mentioned before was student payloads and student flight missions. We have one of the larger programs that we're running is the Retrospectives program. That's a shared program between Sweden and Germany, where we offer flight opportunities for European student payloads as well, not only Swedish and German student payloads on a sounding rocket to fly out of Esrin Space Center. So the rocket we fly for these specific types of flights are the improved Orion rocket that reaches roughly around 90 kilometers of an altitude. And from how these programs are sort of built up is that first off, there's involved training of the students with how to actually build these types of equipment for a sounding rocket or for a sounding balloon for that matter as well. How to do a full project cycle and what that actually means. We do help them out with reviews of the projects themselves and what they build. Then the student build and design the full aspect of the experiment. And then we launch it out of Esrin Space Center together with other student-based payloads. And then we have sort of a post-launch wrap-up and study a bit what went wrong and what went good, sort of lessons learned. And this sort of to build up as sort of a lifelike of a project as possible in terms of space, so that students themselves have a relevant experience of space projects before leaving the university, so to speak. So a lot of the engineers that we actually get straight from university, from our SSC, have or are involved in this sort of program. So this is a good program from our point of view as well. This program can of course be expanded in a large variety of ways. I'll come back to that a little bit later, but this is an example of one student payload that the group built. So basically they wanted to do infrared spectroscopy of selection of different atmospheric levels to study the composition of those levels. So what they did is that they built free-falling units that they ejected from the sounding rocket. Those units were falling through the atmospheres and doing a reading during the descent. And then at 46 kilometers of an altitude, they opened up a parachute and then descended into our impact range, where the students, together with us with helicopter aid, went out and fetched the free-falling units that were tracked with GPS and got them back. So this is one sort of example on a type of payloads that usually fly on these type of rockets. There's quite a wide variety of different payloads that we fly for students. It's all for atmospheric research, material science, other deployment systems, control systems. It's both the sort of technical part. They want to study specific demonstration payloads for fields they have studied as part of the university time, or they study specific physical phenomena that they want to explore further, or new ways to explore a specific phenomena in space. We've had quite a reach, more than 1,400 direct participants in the program, quite a lot of references and published papers by the students themselves that have been involved in this, and the public reach is also quite large. The students themselves are very happy about taking part in this program. They say that it has increased their interest in pursuing a space-related career. They say that definitely these types of student projects have helped them in this aspect. And in the end, a lot of these students are employed in the space business afterward. And most of them say it's a great opportunity to take your sort of theoretical knowledge and actually put it to a practical application, which can be quite rare in a university setting. So what we sort of propose, there are different types of models on how to do this. We see that we already here at S-Range have the infrastructure to support all of this from day one, so to speak, to help out with the training and the programs that we're running. So it would be quite little work for us actually to help out sort of students and setting up so that Icelandic students can fly out of S-Range, either on a dedicated rocket or as part of an already built up sounding rocket with other payloads, or that we conduct a campaign on Iceland as well. It's also an alternative for building up capability locally in Iceland, both for sounding rocket launches and for stratospheric balloons. So when it comes to launching rockets from Iceland, there is a heritage. Basically in 1964, there was CNES researchers launching sounding rockets on the southern part. I think the area was called Vík, on the southern part of Iceland, for Aurora research. So this was 4 sounding rockets going to 450 kilometers of an altitude for Aurora Borealis research. Some of these discussions I've had with Thor on Space Iceland was that it's quite a shame that a lot of the knowledge from back then wasn't really kept or maintained, because take it into perspective that in 1964, that's when roughly we started launching sounding rockets as well, and we sort of built up the capability with S-Range Space Center as well. So it's a shame that that wasn't pursued in Iceland. But we see that based on the recent activities and the interest of the Icelandic government, there is a possibility to rebuild parts of this knowledge and experience on Iceland, and we want to be a part of helping that. So we see that there's a lot of interest from commercial companies and internationally to do flight campaigns based on greenfield ranges. So that means ranges that don't have access to a lot of infrastructure. There's quite a lot of perks for doing these types of rocket campaigns from greenfield ranges. There's a lot of flexibility involved in doing this. Also, in terms from an Icelandic point of view, you have large and uninhabited areas, both over land or sea. You have the access to doing Aurora research based on your latitude. You have a very business-friendly climate and strong institutions in Iceland, and solely based at being a Nordic country. We see that sort of the missing puzzle piece to fully enable this would be a regulatory framework, and actually having some sort of vetting process for how to operate these rockets safely from Icelandic soil. And this is where we see SSC coming into the picture. we would sort of propose, we want to sort of start dialogues with the Icelandic government to see how can we help setting up a process that's a bit more lenient than the current process that was done with Skyrora, which was quite bureaucratic based on the information I've heard at least, and making a more lenient process where we could help setting up and see how can we do these types of things as safe as possible, and in what type of locations is a good way to do it. So basically what we can support with is sort of vetting for this, and also support with simulations and analysis work based on our existing tools and models for doing this that we use from the launching base and also from our mobile operations that we do today. And we can also support with mission management, ground safety, flight safety, clearances and licenses, and infrastructure support if needed. So basically what we want to say is that we want to help out Iceland grow as a space nation, and in these 3 respective fields. Thank you. If you have any questions, my email is here, and I think I saw some questions popping up in the chat as well.
Yeah, I don't see any questions in the chat, but if anyone has one, please give us some. Maybe, Christian, you can ask one of your colleagues to create a fake question. We do that every now and then. So if anyone wants to raise their hand, anyone has a question? Okay. Well, speaking of because you mentioned the Skyrora launch, I mean, I think one of the things that we saw there is how unprepared the legal framework in Iceland is for this. That was one thing we saw. It's quite fragmented, so it was quite complicated to, and there was a lot of uncertainty in trying to secure it. But at the same time, the lack of a legal framework also meant that really wasn't like a legal authority to limit certain aspects or really. So this is something that we are actually working on right now. We've been going over some international treaties related to space and how Iceland has implemented them, and actually a surprising number of space or sort of major space treaties have been signed by Iceland. I mean, potentially because of the launch 50 years ago. But any questions? Any?
We have one question.
Brilliant, thank you.
So
I'll bring you over to Alpha.
Does SSC have a CubeSat project going on that can help with the Icelandic CubeSat project?
So currently we do not have a CubeSat specific project going on. We have engineers that have experience from CubeSat projects, including myself. Actually, I used to work in a company that was building CubeSats in the past. But no, we don't have a specific CubeSat project that's running right now.
All right. Any other? I'll give you a filler question while we wait.
Sorry, there's another question.
Brilliant.
So what kind of projects SSC wants to support here in Iceland? Is it only regarding rocket launch, or are you looking into anything else?
Yeah, as I mentioned, we want to explore sort of what are the research activities that Iceland is doing today in terms of moon research, because we're actually actively looking for moon researchers right now, and if there's an interest to do to work on lunar payloads, to do in situ research on the moon.
Okay.
So outside of rocket projects, so to speak, that's the sort of area where we have been looking at together with the Space Iceland.
Thank you. Christian, can you maybe, while we wait for another question, give us some thoughts on why countries like Sweden and Norway, and well, most of Europe actually, are so focused on having the capability for launching, and most countries are spending considerable amount of money to attract these things. So what is the benefit in your view?
So basically, there's a wide variety of actually answers to that question, but Sweden has a very long heritage when it comes to specifically sounding rockets. So that means the rockets going in a ballistic trajectory from, let's say, 100 kilometers all the way up to 800 kilometers. So that's sort of our niche, and a lot of microgravity-based research. So in the end, what we see with these types of sounding rockets is that we're building a multitude of capabilities in Sweden, and that's quite relevant to also our industrial sector, because there's a lot of space activities and the sciences that are involved in space that have quite a large plethora of different research areas going into it. So that basically means that building a good capability for science and these type of activities are very good doing with a sounding rocket-based type of rocket. So basically you're building both experience from on the rocket part and also in terms of the specific science that you're doing on these space-borne rockets. Because a lot of, for example, material science are based around you have to understand how the material is behaving in a certain environment. And it's quite hard to isolate specific environments for studying materials. So specifically in that field, it's extremely good to do microgravity research. And the payload and the sort of flight vehicle of choice for Sweden has been sounding rockets to do these type of flights. But also based on the orbital capability, which we've been focusing on now for the past couple of years, is a big area that we're focusing on right now, sort of the extensioning and building out of the new base area. So that means that we're actually partnering up with the European-based launch vehicles to launch orbital class vehicles out of S-range. So that's sort of the next step, at least in the Swedish position, to foster a new type of market inside of Sweden to actually launch our own satellites domestically from Sweden. So focusing on space and focusing on these types of research area, it does not only affect the sort of space activities, it affects so many other research topics outside of space. So we're sort of building a larger community of researchers around these types of flight vehicles, which has been extremely beneficial for Swedish research in the past.
Okay, we have another question. So what does the SSC provide for the development of the projects? Do you have like an economical support or something else?
So basically what we are looking at is we want to start up with setting up a sort of bilateral discussion between Sweden and Iceland, and sort of in what way should we focus on these activities, and what would sort of be also in terms of good funding scheme for building these capabilities on Iceland. So I would say that's part of a bilateral discussion between the Swedish state and the Icelandic state. So we want to sort of kickstart this discussion here from our end and sort of kick it up a notch to the bilateral level, so to speak.
Okay,
There's another question.
Another question, yeah. So Iceland has an empty chapter when it comes to advanced aerospace technologies, so it is relatively hard to find much help about the engineering studies in space fields. Is it possible that SSC can provide guidance and advisor in students' project that is related to communication system? Final BC's project, and which will be used in the CubeSat of Space Iceland. Yeah, and that's the question.
Yeah, so when it comes to sort of communication systems, so that's one of our expertise areas based on sort of our ground communication and similarities. We have a lot of projects going on now where we're building out the capability to support more in terms of CubeSats and smaller satellites through our ground station constellation network services, basically. So that means we've built up quite the expertise when it comes to that area. So yeah, I think we could definitely help out with some expertise there.
So I'm going to ask a question. In your presentation, you mentioned quite a lot of research paper and citations. I mean, this is obviously something that matters to academia in Iceland. Have you found that your work and the research that you sponsored has sort of pushed up citation? Because I saw 60 peer-reviewed articles. That is quite a lot, actually.
Let's see if I can bring up the presentation again here and share screen.
So is that perhaps part of the Swedish space policy to push for more citations and peer-reviewed articles?
I mean, basically what we want to do with these types of programs, especially through Sweden and Germany that are financing this specific program that I'm talking about here, is that we want to enable students to try out their technology. But as you say, academia is extremely interested in having peer-reviewed journals and articles based out of these flights as well. So the focus from the university has been to sort of steer a little bit in what directions some of these students actually do their research, so that that can be applied for deeper university researchers as well. So it's not uncommon that you have a PhD student or a professor leading a student project, and then the students are sort of building the rest of the student payload. But this sort of scientific scheme in the background is the PhD or professor that want to have a specific field studied.
All right, thank you. Any other questions? All right, that's good. So, well, just thank you, Christian. This was great. We're always happy to have someone to talk at our meetings. This is the first one in a little bit, so thanks for attending. Just quickly on some of the things that have been happening lately. I think it's fair to say that things happen quite slow when it comes to space policy in Iceland. Well, I mean, they do happen quite quickly, but when it comes to any sort of policy or legal changes, that is actually quite difficult. At the moment, we are preparing and sort of looking over, doing some groundwork for the national space policy that needs to be created. So we have a long time ahead of us there, but we are also doing sort of temporary work to understand the framework that we have and to make sure that nothing is stopped. As you know, we have elections next year in Iceland, and innovation is the new big thing, which should benefit space, and we are working very hard that it benefits us and sort of space-derived industries or any sort of basic research. But those of you that are also in Iceland do probably know as well that it's quite sort of a shallow way. The way innovation is mentioned in Iceland and sort of utilized by politicians is quite shallow, actually ridiculously shallow, and is total nonsense. But we are working hard on changing that. And I know this has been recorded, so that's fine, because I think the message we need to get out, as always, is that innovation and basic research is a long-term thing. You can't just push a button and it happens. And it's not all going to happen in garages in middle-class suburbs. So we'll be working hard on that. We will be publishing a report soon where we mapped out strengths and opportunities actually, unfortunately, quite a lot of lost opportunities because no one returned emails at the government level. And then kind of go for a strategy on from there. And finally, I want to let you know what we've been doing lately. As Christian mentioned, we've been having sort of some discussions with SSC and a few other companies all over and some national agencies. There is quite a lot of interest in Iceland. So we are trying to make sure that we can remove any hurdle for anyone to do business here and help out with how fragmented any sort of permit process is in Iceland, because there is no space agency in Iceland. There is no space, there's no centralized space policy or decision makers. So it is very fragmented, and that's where we come in and try to help. We recently published a review of the Parliament budget, which is, it's fair to say that we were not impressed. We've tried to be, Space Iceland has tried to be quite sort of helpful and not too critical of the government, but this budget is an absolute disaster for young people and innovation. And I think it's fair to point you guys to read it and look into it. Just as an example, there is some public investment, despite endless talk about innovation and public investment taking us through the COVID crisis, is going up by 2.1, I think, billion ISK. Now, billion in ISKs actually isn't very much. So and the reason for that is that the government has decided to push up governmental investment, but then push the local government for austerity, which means that in effect it's not even keeping up to the good years. So these are the sort of things that we are pushing the government to work on. We are constantly meeting them. We are working with local regional development agencies. We're also looking into the dismantling of the Innovation Center, which is also a new governmental policy, an attempt to further innovation in the country by destroying the only central institution that we have. I would say that personally, although Space Iceland has not still formed an opinion, we've been looking into it, and you might have seen in the news that the minister denied that he was dismantling it, and therefore we couldn't get information. But then once it hit the news, they subtracted and said it was absolutely being dismantled, but we couldn't get the information. So that is so we are still in a process of trying to get the information so that we can give you information and form an opinion. But I can tell from my view that it's literally the dumbest idea I've ever had. It's a design of failure. You do not, if you think there's a lack of cohesive plan in innovation and a lack of information and lack of sort of a network, closing the only, despite possibly faulty public central agency is literally the dumbest idea that I've ever heard. So again, we are still looking into the effect of it. I think that's it for now.
Yeah, we have one more question to Christian.
Brilliant.
Yep. So it's do you, Christian, have examples of how local communities benefit from making room for space research?
How local communities benefit from making room for space research? That's quite an interesting question. So there's quite a lot of depth to this specific question, I would say, because a lot in the past, when people are building rocket rangers and similarly, there's usually always talk about conflict and a conflict with local people and their activities in that specific areas. But based on our activities in northern Sweden, we have quite the opposite experience from us, at least. we are working quite a lot with we have a large indigenous community in northern Sweden, indigenous people called Sami people, which is a part of Finnish Ugric native people on that northern part of the Arctic. And we are working very closely with them because they do a lot of reindeer activity inside of our rocket range, actually. So they roam the rocket areas more than we do. So that actually means that they know the land, they know the rocks, they know the fields much better than we actually do. So when we launch things into the field, they are usually the first people to find them and actually help us locate specific things or inform us that there's maybe problems with the specific areas of the range, or there's maybe not as much snow as reported in specific regions. So from our point of view, we've had very good experience working with local communities in space and do a lot of activities together when it comes to space activities. So it depends on how you do it, I would say. That's very vital to sort of the execution. You can't just go to an area, start launching rockets or releasing balloons or similarly, or do any type of space research in an area without having an agreement with the local population or the local groups that have an interest in that area. And also, of course, we have when setting up these activities, there's a lot of, in the end, you're building an ecosystem. So there's a lot of universities that are attracted to these types of research. There's more skilled labor being attracted to the region as well. So that greatly benefits the region.
Thank you.
So sorry for the long answer, but it's a it's a complicated question.
Yeah, no, but it's a good question and a good answer.
So it was a great answer, actually. So should we end it now? We're just about to reach an hour. Obviously, we can continue for those that want to, but it seems that we kind of reached the end.
Yeah, so from my end, I just want to say that for those who want the presentation, I can send you the presentation. I showed my email at the last slide, but if you didn't get it down, you can contact Thor. He can probably give you my contact information. I would be happy to talk about doing activities together on Iceland.
Yeah, fantastic. Yeah, if anyone needs to reach Christian, they can send me and Alpha an email. My email is thor@spaceiceland.is, and Alpha's email is alpha@spaceiceland.is. Although I would say that it's ALF, not ALPH. And we'll also get everyone in touch if you have any ideas. So thank you guys for the meeting. This was quite fun, actually. We'll have another one. Is it the 7th of December, Alpha?
No, the 3rd.
It's the 3rd of December?
Yep. It's the so the first Thursday of December at the same time. So at 1:30 on local time. It's 1:30 GMT.
And we've also, if you subscribe to the newsletter, if you don't go to spaceiceland.is, subscribe to it, you should have all the dates for the next year. We tend to organize the dates for these meetings a year in advance. We're always looking for speakers. We're quite open about what constitutes space activity. Even if you're just designing a game that happens in space, we do feel culturally connected to you guys. So send us an email if you have any opinions, and remember that we'll probably have a discussion on the budget at the next meeting in December, but then we'll definitely have a nicer, more interesting speaker as well. But the budget is important for the sector. All right, cheers guys, and thank you.
Thank you, bye.
Bye-bye.